Hello friends, in this video I am going to discuss about the insertion in a binary search tree. So the insertion can be done in two ways, that is in a recursive way or in an iterative way. So in this video I am going to explain it in the recursive approach. So we are going to discuss about the insertion in a binary search tree. Let me just give a pictorial representation in the way to describe how the insertion takes place in a binary search tree. So let me just draw a small binary search tree in order to make you understand what is the process behind this, that is what is the logic, underlying logic in this insertion process, and then after that I am going to discuss the function or the algorithm of the insertion process in a recursive manner. So suppose this is a binary search tree. Suppose this is a binary search tree, this is 5, this is suppose 8 or this is 15, something like this. So this is a binary search tree. If we want to insert any node into the binary search tree, then what we will do? So suppose we are going to insert a node like this. So the node contains a value, suppose it contains a value of 6. What we will do? In this case, in every case rather, we will compare this value with the root node value of the binary search tree, that is the 10. That is here it is 10. So 6 will be compared to 10, and if 6 is, and if this value is less than 10, we will go to the left side, left subtree, and do the insertion process there. And if the value of this value of the new node is greater than this root node value, then it is to be inserted on the right subtree. So here we see that 6 is definitely less than 10, and so we will look towards the left subtree, that is we are going to this 5, and this left subtree starts with this node having a value of 5. So we will again do the same type of operation, that is we will again compare this 6 with this root node value 5, root node value of the left subtree with respect to 10 as the root node. So this 6 is then compared against 5, which says that 6 is greater than 5, so it is to be inserted on the right subtree of this left subtree. So we go to this right subtree, we never go to this left part, and we come over here. So becomes 8 becomes the root node value now, and we are going to compare this 6 with this 8, and this 6 is less than 8, and that's why 6 is to be inserted on the left subtree. So if we find that the left subtree is null, left subtree is not there, that is this left pointer of this node points to null, then we will just insert the node in the left subtree like this. So 6 is to be inserted on the left subtree of the node containing the value 8. So the left pointer, which was originally null, pointing to null, it will now point to the address location. Suppose it is in the 65586 location. So 65586 location contains the value 6, and the left pointer of this node, suppose it is 75586. So this left pointer of 75586 will contain a value of what? 65586. So in this process we are going to insert the new node in case of a binary search tree, so that after the insertion the tree remains a binary search tree. In this process we can insert a new node. So we are going to write the code or the function or the algorithm of this insertion process in the way of a recursive function. So in this video I am going to present it in the form of a recursive function, and in the later video I will just go on explaining this process in an iterative way. But for now we are going to write the recursive function or the recursive procedure of this insertion in a binary search tree. So let's write the code and come back to you. So as I have written the code, let me explain you what I have done. As you are familiar with the structure definition of this binary search tree, so let me write it once again. Type def struct BS node int data struct BS node star left star right BS node. So this is the structure definition as we have already discussed in previous videos. So what we will take in the function as the arguments, a pointer to this BS node structure, that is the root, and another pointer to the BS node structure, that is the new node. What is the new node? This new node is the node which is to be inserted into the existing binary search tree. So these are the two arguments. It is not going to return any value, that's why the return type is void. I have named the function as recins to denote that it is a recursive insertion procedure, and after that we come into the function body. What I have written over here, if root data greater than new node data, then what is to be done? Then the new node data is less than the root data. So in that case we will insert in the, we will go towards the left subtree of the root and then go on to try to insert the new node on the left subtree, on any part of the left subtree. In that case, if we see that if root left is null, is equal to null, we are going to just join the new node to the left pointer of the root. So in that case, it is to be done in a direct manner. Otherwise, we will just go on do the recursive way of inserting the new node in the left subtree by calling the function in a recursive way, that is recins is called with respect to what the two arguments are now, root left, that is the address of the left address of the root of the left subtree, and the new node. So the function will again work in this process, and in this way it will go on. So suppose I will just give a small example in order to make you understand what is going over here. Suppose I am going to write this. This is 10, this is 5, this is 15, and suppose the new node is, say, suppose 8. So the new node address is 65586, this is 75586, this is 855, this is 85586, these are the locations, memory locations, this is 95586, something like that. So in this case, what we will do? Suppose we will see what we have to do over here. This BS node star root is nothing but 75586 when we enter into the function for the first time, and this new node address is 65586. So suppose we are entering with 75586 and 65586, and now here we see that if root data greater than new node data, see this, root data is definitely greater than the new node data. New node data is 8, root data is 10. So we will come inside this if block, that is, if root left equals null, see, root left is root left null, root left is 85586, it is not null. So this portion will not be executed. We come to this else portion. And see what I have written over here, recins root left new node. Again we will call the function in a recursive way, that is, the function will call itself with the arguments, that is, root left is now, which one? Root left is now 85586, and new node is just like in the previous manner, it is 65586. So we will again come to this function and execute the function in this way. So now it is 85586, 85586 and 65586, sorry, 65586. Now we will enter this function once again. See this, if root data greater than new node data, see this, root data is greater than new node data, no, it is root data is less than the new node data. So we obviously come to this else portion. So this if portion is skipped, and we will not execute this portion. Come to this else portion and see what I have written over here. If root right equals null, suppose this root right, what is this root right? The root is now 85586, the root right is null, definitely it is null, and what I have written in that case, root right is equal to new node. So root right will be is equal to new node means root right will be set to 65586. That is, root right will be pointing to this node containing the value 8. So in this way we see that it is inserted. This 8 is inserted in the left subtree of this binary search tree. In that case, again we see that this root right is equal to new node means we have joined it. So in this way, see this, if we come to this, we are not in any way are going to go through the entire recursive procedure, because we have entered a boundary condition, that is, if root right equals null, this is the boundary condition, and from which we get out of the recursive process. So in this way, see this, and we are going to the end of this function body, and we see that this node containing the value 8 has been inserted into the binary search tree in its respective position in a manner, in a recursive manner. So this is the entire logic of the code which I have written in this process. So if you have any doubts or queries pertaining to this example or this code, you can just post your doubts and queries into the comment section below so that I can address them. Thanks for watching this video.